What is pre-cooling? The pre-cooling process is the removal of field heat immediately following harvest, where field heat accelerates the deterioration and senescence processes. In post-harvest systems, pre-cooling is a crucial step in preserving high-quality fruits and vegetables and the most crucial of all the processes required to maintain any acceptable, fresh, and marketable fruits and vegetable production. These are the advantages of pre-cooling process. It removes the field heat. Field heat, the difference in temperature between the temperature of the crop harvested and the optimal storage temperature of that product. For example, if you harvest a berry at an ambient temperature of 22 degrees Celsius and the best temperature for extended cold storage is 1 degree Celsius, your field heat is 21 degrees Celsius. Increases the shelf life of fresh produce. Storing produce in cold temperatures with appropriate relative humidity levels protects fruits and vegetables from decay and bacteria. This extends the shelf life, which in turn extends the product's selling period, reduces the rate of respiration. Low temperatures decrease cellular respiration in living tissues. As the temperature rises, the kinetic energy required to engage in chemical reactions like cellular respiration goes down. Therefore, warmer temperatures typically result in more cellular respiration. Reduces ethylene production. Ethylene is a gaseous plant hormone that plays an important role in inducing the ripening process for many fruits, together with other hormones and signals. An unripe fruit generally has low levels of ethylene. As the fruit matures, ethylene is produced as a signal to induce fruit ripening. Limiting of microorganism growth. Colder temperatures inhibit growth of both existing and new microbes. There are things we need to consider in pre-cooling process. Size. Small, medium, large to have a classification of the produce. Temperature. The initial and final temperature of the product. Packaging. The way produce is being packaged makes pre-cooling methods more or less suitable. Flow rate. Products also differ in their flow capacity. The faster products can be cooled down, the better. Characteristics. Characteristics of produce, such as chilling sensibility or the need for rapid heat removal. Method. The methods to be used due to some produce cannot get in contact with water. There are 4 main methods for pre-cooling. Cold air cooling. Hydrocooling / cold water cooling. Top icing. Vacuum cooling. Now what is cold air cooling? We have room cooling. Heat is transferred slowly from the mass of the produce, by convection, to the cold air being circulated around the stacked containers. This is most common and widely used method. Here cold air is passed from the fan and cool by convection process. Its commonest use is for products with relatively long storage life and marketed soon after harvest. Advantages. Clean and simple. Low installation and maintenance cost. Provides temporary storage after pre-cooling. Disadvantage. Slow. Uneven cooling at the beginning. Not suitable for leafy vegetables due to prolonged cooling hours, resulting in dehydration. 2. Forced air or pressure cooling. In this system, cold air is passed by force from one side to other side using big fan. Cold air movement is through the containers rather than around the containers. Air is blown at a high velocity, leading to desiccation of the crop. To minimize this effect, air is blown through cold water sprays. Adequate airflow is necessary. This is because fruits in the center of packages tend to lose heat at a slower rate compared to those on the exterior. Advantages. Clean and simple. Rapid. High heat transfer performance. Low installation and maintenance cost. Disadvantages. Slower as compared to vacuum cooling. These are crops usually pre-cooled by force. Hydrocooling / cold water cooling. We have shower/batch type. The water showers over the commodity, which may be in bins or boxes, or loose in a conveyor belt. A common design is to transport the crop on a perforated conveyor belt. The speed of the conveyor can be adjusted to the time required to cool the crop, and cold water is pumped from the tank and allowed to fall on the produce in sprinkled type and then falls through to the tank below, then filtered, recycled and recooled. Immersion type. It is simplest type of a hydrocooler in which produce is dipped in cold water. Here product are normally in bulk, is in direct contact with the cold water as it moves through a long tank of cold. This method is best suited for products that do no float, because slow cooling would result if the product simply moved out of the water. Advantages. Rapid. High energy efficiency. Provide means to clean vegetables, e.g. with chlorinated water, to prevent spoilage. Disadvantages. Additional step of drying required. Additional effort required to monitor water quality and cleanliness of cooler daily. So these are the crops normally hydro-cooled. Top icing. This is one of the oldest ways to reduce field temperature. It is commonly applied to boxes of produce by placing a layer of crushed ice directly on top of the crop. It can also be applied as an ice slurry made from 60% finely crushed ice, 40% water and 0.1% sodium chloride to lower the melting point of the ice. Advantages. Rapid. High heat transfer performance. Prevents any moisture loss from vegetables. Disadvantages. Additional weight from crushed ice and high water content from melting ice could increase the risk of physical injury and rotting of vegetables. Risk of chilling injury to vegetables if period of icing is prolonged. Some of the most crops suitable for ice cooling. Vacuum cooling. Leafy vegetables are commonly cooled by reducing atmospheric pressure in artificial hermetically sealed chambers. Reducing the atmosphere pressure also reduces the pressure or water vapor in the chamber and thus cooling is affected. The outstanding advantages of vacuum cooling are the speed and uniformity of cooling of adapted commodities. Advantages. Rapid. Uniform cooling for all vegetables. High energy efficiency. Disadvantages. Risk of wilting due to moisture loss. High cost. Requires packaging with holes for water evaporation. Crops suitable for ice cooling. Beans, lettuce, mushroom, spinach, carrots, capsicum, celery, corn, leafy vegetables, cabbage.